Before we look at the worksheet corrections, let's take a look at what is an exothermic reaction and endothermic reaction. So this is just an overview. So when we look at exothermic reactions, we always think of heat being given off. Okay, which means the system is giving off the heat. So the system can be anything. And it is giving off heat to the surroundings. So because the heat is being given off, therefore the temperature of the surroundings or the container or the reaction mixture, because when you measure temperature, you use a thermometer to measure. So the temperature of this entire surrounding will be increasing. Okay, because heat is given off, so you can feel that heat, so the temperature goes up. Okay, and because heat is given off means that my products have less energy than the reactants, because the reactants gave off some energy in the form of heat. So my energy of products is less than energy of reactants. So how do we find the change in energy or change in enthalpy? What we do is the product minus the reactants. So since this is less than the energy of reactants, our delta H will be a negative value. So once we have covered what is exothermic reaction, which is heat is given off, temperature of the surrounding rises, the energy of products is less than the energy of reactants, therefore the change in enthalpy is a negative change. The last thing when we talk about exothermic reaction, we usually talk about bond forming, or it could be that in the reaction there is bond forming and bond breaking. However, more energy is released by bond forming than needed by bond breaking. So in the end, the reaction is still exothermic. So what are some of these examples in our daily life? So for example, in our physical processes, when we are trying to increase the forces of attraction, that means we are trying to get the particles to be closer together. Meaning for our gas to liquid, we have condensation. Or when we have liquid to solid, where we have freezing, which could also known as solidification, as well as from gas to solid, which should also be known as solidification. All these are trying to increase the forces of attraction. They're trying to get the particles to be nearer. Therefore, it is sort of similar to bond forming, which is why these are exothermic reactions. Okay. Other than that, if we want to dissolve any anhydrous salts, that means the salt has no water or crystallization in it, or we want to dissolve acids in water, this could also be exothermic. Okay, and finally, for chemical processes, we have combustion, neutralization, rusting, and oxidation. So you can recognize any of these chemical processes, likely they are exothermic reactions. So now we'll take a closer look at temperature of surrounding or temperature of container or reaction mixture rises. How then do we draw a temperature time graph? So temperature is in degrees Celsius, time is in minutes. Usually our solution or our reactant starts at room temperature. So I'll put here room temperature. And what happens then at room temperature is it will start to go up. Okay, so it will increase because temperature rises until the maximum temperature. Maximum temperature, depending on how much heat is given off. Then once the reaction is complete, what happens is, since the reaction is complete, slowly this temperature of the reactant mixture will start to drop back to room temperature. So you will then draw it deep down until it hits back room temperature. Okay, so ensure that the lines are accurate, okay, as well as this. Okay, so make sure the points are accurate. Okay, and how then do we remember exothermic reaction? One way is to remember exo sounds like exit, where heat is leaving the system, heat is giving off from the system. For the next one, we talk about endothermic. So endo is heat is taken in. Meaning the surrounding have to supply heat to the system. Okay, so because the surrounding has to supply heat into the system, what happens? The temperature of the surrounding will fall because it's supplying heat into the system. Okay, and because of that, the energy of products, so because the heat is being taken in, the energy of products is more than the energy of the reactants. Okay? So when you do your enthalpy change, what you have is a positive value. Finally, why must heat be taken in? Is because a lot of this is used for bond breaking. Or if the reaction has both bond forming and bond breaking, means that more energy is needed for bond breaking than released by bond forming. Okay. So what are some of these examples? So for example, if it's a physical process where we have gas, liquid and solid, here we are trying to so-called break the bonds, which means we are trying to overcome the forces of attraction. So it's this way. So what we are doing is we are trying to do melting, we're trying to do boiling, where we overcome the forces of attraction, or we're trying to do sublimation. Okay. The other possible endothermic reaction is when we dissolve soluble salts in water. And for the chemical process, the most common one is thermal decomposition, where we are breaking up the substance. For endothermic reaction, let's look at the graph. So we're talking about the temperature dropping because heat is taken in by the surroundings to break the bonds. So it starts off at room temperature first, which is 25 degrees, and then it will slowly come down to the minimum temperature depending on how much heat is taken in. And once the reaction is complete, it will start to slowly go back to 25 degrees to room temperature. Okay, so again, same thing, this will be the minimum temperature. Ensure that the lines are straight. So you could use a pencil to dot the lines as well. How do you remember endothermic reaction? Endo sounds like enter, so you can think of the heat entering the system. Okay, so this question is asking which of the following reactions are exothermic. So first of all, we recall that exothermic means heat is given off. So we write that it gives off heat. Okay, then now we take a look at each one. So if it's solid to gas, what's happening here is our solid is moving to gas, sublimation. They are trying to overcome the force of attraction, which means it's similar to bond breaking. Therefore, it is endothermic. So I will write this down, sublimation, because of the state symbol, solid to gas. It takes in heat, which means more energy is needed for overcoming the forces of attraction, that's why we call it endothermic. The next one, solid, is a solid substance breaking up into two different substances. So this is called your thermal decomposition. Thermal decomposition. Again, in decomposition, we are breaking up bonds. So therefore, it's endothermic. Final one, if you look at this, carbon, solid, reacting with oxygen. So when we see this carbon reacting with oxygen, we can think of combustion, or we can also think of oxidation. So either one of these, combustion or oxidation, is under here, which means we're talking about an exothermic reaction. Here, another way to see is combustion is burning. It always gives off heat energy. That's where we know it's exothermic reaction. So the answer would be B, only 3 is exothermic. Okay, for the next one, we talk about exothermic reaction again, and they're asking you to deduce. So exothermic reaction means that all this may happen. So when we look at all the answers, yes, the temperature will rise. Okay, so A is the correct answer. Heat is absorbed, that is not true. Heat is given off for exothermic reaction. Enthalpy change is positive, that's not true. Enthalpy change is negative. Surroundings become colder, that's not true. Surrounding becomes hotter. Next question. Why is the reaction exothermic? Okay, so when we talk about exothermic, we are talking about bond forming. Okay, or that more energy is released by bond forming than needed by bond breaking. So we look at this, answer is D. Some of you may have the question, why is it not option B where more bonds are formed than are broken? Okay, the reason is it's not about how many bonds are formed or how many bonds are broken, but it's about the energy released when forming the bonds or the energy needed to break the bonds. So it doesn't matter if there are many bonds being formed and as much bonds being broken. Okay, it's regarding the energy that is needed or released. Burning fuel such as combustion is an exothermic reaction. So let's see which statement explains exothermic. Okay, so the option is C, energy is given out and there is an increase in temperature. Option D is wrong because it says energy is taken in. Option A is wrong because molecules, when they react, can be releasing energy or can be taking in energy, depending on what's happening. Okay, and again, option B is not valid. Okay, next one, question 5, talk about exothermic reaction, asking you about the change in temperature. So remember, exothermic, what happens is it's giving out energy, so the temperature will rise, and then when the reaction is complete, it will fall back to room temperature. So I wrote this down here so that I know what am I looking for. So if you look, A and B are both temperature rising. And then when it's complete, the temperature should go back to room temperature. So the correct answer would be option B. So for this question, the first part of it, they ask you what's the chemical formula. So if you look at your periodic table, sodium is group 1, so Na+. Carbonate is a polyatomic ion, CO3, 2 minus. We need to balance the charges. This is 1 plus, this is 2 minus. So we need one more sodium. So once we put that in, we have 2 plus, 2 minus, charges is balanced. So we write Na2CO3. Next one, potassium nitrate. Potassium is group 1, K+. Nitrate is a polyatomic ion. You have to memorize it. NO3. Charge is minus. 1 plus, 1 minus is balanced. So you simply write KNO3. Okay, for the next part, they have given you the temperature of the solution. This is the final. And this is the initial, which is temperature of the water. Then they ask you for the temperature change. Okay, so temperature change, taking 34 minus 25, because temperature change is always the final minus initial. So 34 minus 25 gives you 9. We put a positive sign to show that the final temperature is higher than the initial temperature. For the next one, 19 minus 25 gives you 6. And we put a minus to show that the final temperature is less than the initial temperature. Then what else? Temperature change here in the table doesn't have the units degrees Celsius. So you have to add the units in degrees Celsius, degrees Celsius. Okay, next question. State the type of energy change for anhydrous sodium carbonate dissolving in water. So before you even do the question, if you can remember that dissolving of anhydrous salt in water is exothermic, you would guess that this is an exothermic reaction. But if you didn't remember that, then if you look at the temperature rising, final temperature is higher, means again it must be exothermic. Reason is there was an increase in temperature of the solution, okay, which is about 9 degrees Celsius, which means that heat was given off. So once we know that heat was given off, we know it's exothermic reaction. Okay, for the next one, again, there's another set of results over here. Okay, and here talks about the temperature at the start and at the end. So if we look at this, for experiment 1, the temperature rise, which means it's exo. And if we look at experiment 2, the final temperature decrease, which means it's endo. Okay, so again, this is some point forms that you can find as well on the initial summary, which I transferred it over here for exothermic. So for exothermic reaction, the temperature rises, which means heat is given off, which means the energy of the products is less than that of the reactant. So therefore, delta H will be negative. So when they ask you for exothermic reaction, delta H would be negative. And for endothermic reaction, because the reactants took in heat, so the products will have a higher energy level. So when you do the change, you can refer to this, would be positive. So endothermic will be a positive delta H. Okay, once that is done, then they ask you which reaction is an exothermic one. So experiment 1, because there was an increase in temperature, you may even want to state how much the temperature increased, which means that heat was given off. So again, heat given off means it is exothermic. Okay, and in the space below, sketch a temperature against time graph for experiment 1. So what you should do is you sketch for experiment 1 is an exothermic reaction. So you should sketch a graph like this, where it's a temperature degrees Celsius over time per minute, and the maximum temperature will then be 44, while the room temperature will be 26 degrees Celsius in this case. It should go up and come down. So we draw a graph, temperature. So temperature in this case is in degrees Celsius. Time in this case we are not sure, but usually minutes is a good way to start off with. Temperature start is 26, final temperature is 44. So that means there is an increase. So I'll put 26 somewhere here. 26 degrees Celsius, and I will have a dotted line. So I know that the temperature will drop back to 26 later. And this is just a sketch, so I'll put here as 44 degrees Celsius. And I would put a dot here as well. So this temperature will increase, and after a while it will fall back. Okay, so this would be the temperature time graph.